welcome to everybody on the call. Welcome to Henri. Thanks for joining us again, Henri. As always, it's great to be with you. Henri's from the Microsoft team. I'm Tim. I'm from the CluedIn team. And I'm now going to hand the screen over to you.
And hey, everyone. Like Tim said, my name is Henri. I work as a partner solution architect here in, today, beautiful, cloudy Denmark. I'm going to be spending the next 20 minutes or so just talking a little bit about what has happened in generative AI, over the last 6 months. Some of it, is moving so fast. It's really only happened over the last 2 weeks or so. Those of you who are, let's say, regulars here in CluedIn's webinars, you might have seen me already talk about generative AI. Me and Tim, we were talking about it here in April, I believe. There's been a lot happening, so I think it's important we take a few seconds and recap. For those of you who were not here in April, just a very quick recap from the very beginning of generative AI. This is kind of what we've seen is going on here. The Microsoft story of generative AI starts in 2019. This is when Microsoft and OpenAI began their collaboration. And very quickly after that, things started happening. At GPT-3, you've probably heard about the large language model was announced in 2020. Then all kinds of different solutions based on that started popping up in 2021. The GitHub Copilot, which helps developers write code. Microsoft put it out on Azure, the large language models with the Azure OpenAI service. ChatGPT, of course, really put generative AI and large language models into the public conscience here in 2022. And then, things just accelerated from there. I had been trying to talk to people about generative AI and how cool this was going to be back in 2021, and nobody cared until ChatGPT came out. And now suddenly everybody cares, but that's great. So you've seen things like GPT-4 being announced here this year. CluedIn also jumped on that train. CluedIn has been announcing their Azure OpenAI integration here earlier in the spring. Microsoft has been publishing Bing Chat and Copilots for Microsoft 365 and Windows, and so many other things that have been happening this year. Just in February and March alone, there's been this whole range of new features and capabilities and products being announced that were making use of large language models and generative AI. And this is not necessarily to advertise all of these great products and services. It's more to show you that, hey, generative AI is growing up. We're at a point right now where we are able to build applications that scale to millions and in some cases billions of users with this generative AI technology that just a few years ago was completely unheard of, completely confined to research and experimental applications. And now we are at a point where generative AI is grown up, where it is ready to be used in the business. But there were a few hurdles to overcome. And this is what I want to spend most of the time today with. I want to talk about the 3 past barriers to generative AI adoption and how I think we ended up overcoming them. So the 3 areas that kept people from really adopting generative AI in the very, very early stages of the technology were accessibility, was privacy, and it was reliability. So I want to spend a few minutes on each of these pillars and just talk a little bit about what's the status now compared to how it was in the beginning of the technology emerging. And we're just going to jump straight in. We're going to jump into accessibility. And here when I talk about accessibility, I'm referring to the ability of developers and people to make use of generative AI and have access to that technology. In the very beginning of the technology, this is something that was confined to people who had access to lots and lots of computing power. Large research labs like OpenAI, large tech companies like Microsoft and Meta and Google and so on and so forth. But now you don't necessarily have to have those those supercomputers yourself anymore. We went from this being a field of research on supercomputers to this being available pretty much in every, this level of compute is available in every data center around the world. This has come to the public cloud, and just Microsoft Azure alone has more than 65 Azure regions all across the globe. And 11 of those, marked them here in blue on the slide, are also those regions where you can actually deploy those Azure OpenAI models, and this is quite exciting. Here at Microsoft, we call Azure the world's AI supercomputer. The idea being that you can get access to giant amounts of compute, giant, large-scale infrastructure without having to actually manage all that infrastructure yourself. Now, that means you can train giant language models if you want to. But the good news is that if you're a developer and not a data scientist, you don't have to. If you want to, you can just call APIs and get access to state-of-the-art models like GPT 3.5 and GPT 4 that way. Now, the good news, if you're not a developer, don't worry, because there's plenty of developers out there who are working very hard on building those AI features and capabilities into the applications that you're already working in. So whether that's something like the Microsoft 365 Copilot here that's on the screen right now, that's putting this directly into Word, or whether that's third-party applications. It doesn't have to be Microsoft. CluedIn is one of those companies that's working very hard on making something happen in that space and working with generative AI as well. You'll see many other applications put generative AI into their own flow and into their own experiences. Now, if you are a developer, it's gotten much, much easier to work with generative AI these days. This is not something you have to be a data scientist for to work with. Developer tools like LangChain and Semantic Kernel have made it much easier to orchestrate the building of large language model applications and handle the calls to these large language models in a reliable and predictable fashion. Tools like Azure Machine Learning's Prompt Flow, which is our Microsoft tool for prompt engineering, have made it easier to actually test different prompts, try them out, and then also make sure you can actually test them at scale. Those are just a few of the many, many features out there that are available on the cloud, available as open source packages that make it much easier now to develop applications than it was just 6 months ago. 6 months ago, most of these things didn't exist or were in a completely different state than they are right now. That was my few cents on accessibility. We also need to talk about privacy. Privacy is kind of the core element of when it comes to using AI in a responsible way. And of course, when the technology emerged early on, privacy was not the main focus. It was showing that the technology worked. Things like ChatGPT launched as a public research preview rather than an enterprise-grade, system. We're in a different place today. Customers are building their AI applications now on Microsoft Azure because they can get access to the security and privacy guarantees that they already have for all of their other applications in the cloud. So we're talking here about being able to deploy these services into your own subscription where you are in control, where you can delegate access, where you decide how networking works. The most fundamental principle here is the first one you see up there. Your data is your data. And that means that nobody is using your data to train any AI models. So that includes Microsoft. Microsoft is not doing that. OpenAI does not have access to your data when you're sending it to a GPT-4 model on Azure OpenAI. And if you're using Azure OpenAI through CluedIn, then CluedIn is also not using your data to train any models. So this is a guarantee here that you get when you're working with Microsoft Azure and the Azure OpenAI service specifically. That was very quick, but I think that's mostly also because it's relatively easy. The privacy guarantees have advanced rapidly here, and that's also because customers are expecting it. Customers are demanding it. This was necessary to make it work in order to actually scale this to large enterprises. Maybe one quick note here. I should have brought a slide on this probably, but just remember, if you're not a developer, of course, and you still want to work with generative AI, but do so in a way that preserves data privacy, there's been a lot of announcements here over the summer as well that are interesting. I can highlight, for example, Bing Chat Enterprise. which is kind of like a ChatGPT, but for your own company that keeps data private and secure. So have a look into those options if you just want to be a consumer of AI applications rather than a developer. Now, let's also talk about reliability. And this is the one I left for last because I think it's the one that that's most interesting and that I'm also most passionate about. As a developer myself, I was let's say I was a little discouraged when I saw ChatGPT come out, and many people had to first learn that generative AI is not a search engine. This is something you likely have experienced yourself as well, that if you ask something like, does my health plan cover annual eye exams, to just a standard large language model, you will get, in the best case, you will get a response like this: I'm an AI language model, I don't have access to your specific information or anything like that. In the worst case, you would get what we refer to as hallucinations, that the large language model tries to come up with an answer to your question without having actual information about how to answer that question. Now, so these generative AI models are not able to be search engines. They are not good vehicles for storing information. But that doesn't mean that we can't connect them to something like a search engine. And this is happening with, for example, here, this is Bing Chat, but this is also happening with all of these other copilots that you see popping up on the Microsoft platform and on other platforms as well. The idea being that this is not just you asking and getting some response from an AI and you have no idea how that response is generated or came about, but this is actually about making sure that the AI is just the glue between the user and the data. Here's an example of how Bing Chat works, which is, I think kind of a copilot for the web. The user asks a question, that's in the top here, and then rather than just getting the response right away, there's first a search happening. So Bing Chat, of course, searches, Bing. It's a connected to the search engine, to the Bing search engine there in the background. It searches the web, but it searches the web for something that the large language model has determined it needs in order to answer the question correctly and accurately and factually. So you will see that when I asked for the top announcements from Microsoft Build, which was our developer conference here in May this year, this is something that would normally not be in the training data set for these large language models. So instead, the large language model here, or the Bing Chat, does a search query. Bing Chat searches for top announcements Microsoft Build 2023. And then based on those results, it generates a response. For me as a user, this means that I actually get to see the sources here. This means that not only do I get responses that are more relevant to me, but I can also check where does the data come from. If I'm not sure about number one here, I can just click on the little reference and then find more about it. Read the entire document where the AI took this answer from. This gives me as a user the trust into the response because I know that I can always check and I have transparency. Very, very important. And this is something that we've really seen develop a lot over the last few months. This idea here is referred to as RAG, R-A-G, Retrieval Augmented Generation. And this is what's powering all of these copilots. I don't have the time to go into the architecture, or rather, maybe it's not the right time today, but I think this is super fascinating. And just imagine where this example here is using the public internet as a source. This could be any other source as well. So large language models here behave as the interface between the user and some kind of search index. And that can be the web, it can be a search index over the internet, but it can also be a search index over some data that you have, some data that your customers have, whatever business you're in. It can be files, it can be databases, it can be images. The possibilities here are near endless. And this is what makes retrieval augmented generation so interesting. We're not relying on large language models to know anything. Instead, we are providing them with the data that allows them to make useful responses that are relevant, transparent, and trustworthy. And I think this makes something very, very clear that some of us have already known, but we're maybe a little, went away from during all of this AI hype. The real value does not actually lie in the AI. The real value lies in your data and the way you bring that data together with your users, or you bring that data to your users, to your customers, to your employees. That is where the real value lies, and that is what AI can enable. But it's not the AI that's shining, it's your data. And I think with that being said, we're handing it back to one of the people that helps you make your data shine. Is that a good segue, Tim?
That's a fantastic segue. Excellent, Henri. So listen, we've actually got a couple of questions in. It's funny that last time we were here, the same question was asked, and it was around privacy. And that's why we thought it was really important for you to answer that up front. And I guess we'll just reinforce it from both sides. That really is part of the big value that Microsoft brings to the OpenAI piece. It's the enterprise-ready sovereignty, the certifications, the encryption. This is not saying that OpenAI can't do those things. It's just that Microsoft has that trust and it has that experience of dealing with different countries and dealing with different regulations and what does privacy mean across all of these different countries. So just to reiterate, your data is your data. In a way, that's the reason to invest in the Azure OpenAI pieces instead of maybe integrating direct or going with other large language models. This doesn't negate the reason they can't also support those things, but that's just one of Microsoft's guarantees is around that. There is actually two more questions, and I'm going to actually hold those to the end, Henri. They seem to be targeted towards you, but let's take those towards the end. I'm going to rudely steal the screen back from you, Henri, and we're going to kick in and take over from where Henri left off on, we're all ablaze, we're all amazed, we're all inspired in a way by these large language models and what they've brought. And really, I think where most enterprises are looking at is, great, love the technique, love what's possible. I have my company's data that is just waiting to prove value. How do I get that in a form, in a shape that I can start using these with my own company data? And for that reason, we wanted to put, Henri and I wanted to put together the joint kind of top 10 use cases for how AI will prove value in data governance. And these are ordered by return of investment. So where the biggest investment is going to come and where we should kind of allocate that, that time and effort. So I'm sure you all know Microsoft very well. I'm sure you all know OpenAI very well. And let's double click for those who aren't aware of CluedIn and what it does in context of these other technologies. So to kind of like at a high level, CluedIn is a native master data management solution for Azure. And this nativeness not only comes with the fact that it's built using the building blocks of Microsoft Azure services, things like Azure Kubernetes Service, things like Azure SQL, managed disks, Azure Active Directory, but it also integrates into the Microsoft stack, whether that's Synapse, Power BI, Power Platform, to really kind of fit nicely into that overall ecosystem. And CluedIn bases itself of a couple of core principles. Number one, it's really based on being a platform that's very flexible and agile to be able to work with all different types of heterogeneous data sources, whether it's structured systems like CRMs and ERPs, whether it's unstructured sources like OneDrive or Office 365. it really is about being able to bring this data together and form data that is ready for insight. So at the end of it, this data should be basically ready to build business intelligence, ready to build machine learning models, ready to make operating decisions off due to its higher level of quality. And CluedIn is also a platform that's being built and born in the cloud. And so, leveraging on the automatic scaling, leveraging on the cost economics of running in the cloud, and of course, as Henri mentioned, as of a couple of months ago, adding this facade of the large language models via Azure OpenAI over the top. And what this results in is essentially a platform that is putting the business at the center of the supply chain of data. I mean, for everyone on the call, it looks like we've got people from some of our customers. It looks like we've got people from some partners that are here, implementation partners of Microsoft. And if we think about the technology stacks that we're putting together, they are all inherently quite technical in nature. There's no shortage of tooling in these data stacks that we're putting together for the engineers, for the data analysts, for the infrastructure teams, and so forth. Where is the business? Like, where is the business playing a role in this technology stack? And of course, you could argue that, well, they're definitely playing a role as a consumer of the data at the end of these technology stacks. But what if we could actually bring them into this supply chain? And CluedIn is really focused on enabling those non-technical, non-programmers, non-analysts, non-SQL experts to be able to play a role on the management of data. And of course, providing them with the language via the Copilot prompts, via the large language models, to be able to do some pretty sophisticated things without having those key scripting, coding skills to be able to play that role traditionally. And so what this results in is a cloud native platform that still very much has the characteristics of what you would expect from a master data management system: the matching and the merging, the building of a single record, the survivorship rules, enrichment, cleaning, standardization, audit trails of record changes, but in a very kind of different approach. And all, of course, layered with the Azure OpenAI pieces on top. So we were fortunate enough a couple of months ago to have early access to Azure OpenAI, and that allowed us to not only kind of get our hands dirty on how this integration would look like between the master data management tasks and also the large language models, but it also gave us enough time to run these systems in production with our customers and really iron out a lot of these necessary guardrails to actually have these systems work in production loads on production grade data. And there's a couple of things that, of course, have come out of this, and this is some of what's formed these top 10 use cases we have today. But I think anyone that's kind of touched this new approach with CluedIn is very much agreeing that they would never go back to a non-Copilot world again, due to its ability to augment the experience, in some way automate it, but just help along the way in managing some of these sometimes complex tasks. But what's important is that this is a two-way type of agreement, where obviously we are aware of the power that the large language models can give, but what is it that vendors and integrators like us can give back to the large language model? And this can all be summed up in one word: context. The key in the integration from the CluedIn side is our ability to be able to build better prompts back to the large language model, because it's often with more nuanced, more specific, more targeted prompts, we get better, more predictable results. And here's a simple example. If in CluedIn you were to ask the engine to help you enrich a record that was missing data, you might say something like, what is the annual revenue of this company called Smart Tech Inc., the example we have on the screen. And what CluedIn is doing behind the scenes is it's usually got extra metadata that knows about this company, Smart Tech Inc. And it's going to append those extra pieces to the prompt to help provide a more nuanced answer. I mean, obviously providing it more context, things like, oh, by the way, here's the VAT number, it's in this country, it's in this industry, here's the CEO. More context to be able to provide that more targeted response. And so what this results in is a platform that, listen, if you are, a Microsoft customer that has the Microsoft data stack as a key part of your strategy, then CluedIn's going to fit really nicely in that to be able to bring the use of large language models into a more reliable, more predictable, more operationally friendly manner by providing these guardrails around the use of it. Just things like putting workflows that require approval before we would actually accept things coming in from the large language models. So let's start the countdown. And before we dive in, let me preface this with, I know that Microsoft and CluedIn think about data governance in a very similar fashion. We think about this from not only a defensive perspective, but an offensive perspective. And the truth is that you can't do one without the other. If you are running fast, it's quite easy to get tripped up by not having data that's compliant, not having data that has passed all the regulatory requirements, and doesn't allow you then to accelerate in the end. So it's quite ironic, I guess, that the defensive parts of data governance and getting those as a good grounding and foundation will in the end allow you to accelerate on the more offensive parts that you can tag to the data governance space. So let's start with number 10, and we're going to start on the defensive side of things. And this starts with that very popular use case for AI and data governance will be the ability to detect sensitive data that does not match deterministic patterns. And let's give you a couple of examples. Social security numbers, credit cards, IBAN numbers. These are all examples of quite sensitive data that can fit a very predefined structure. And then there's all these other elements that are also necessary to be able to flag and that would be considered private data, such as names, addresses, job titles that don't really fit any deterministic pattern. They can't be covered via pattern matching or regular expressions. But what we've actually found in practice is even the things that do and should match a deterministic pattern, like social security numbers and credit cards, well, these regular expressions are quite good, of course, at being able to capture that at data entry. But often the case with data governance programs, we are capturing and bringing data together after the case. And we might not have the ability to apply those rigid regular expressions at data entry. And therefore, it's not odd to find things like credit cards that are, have spaces in between each character, or they're missing the last character, or social security numbers that don't have hyphens in between them. And these are things that most occasions you're not going to really be building these pattern matches and regular expressions to be able to capture. And this is really where the large language models can help bridge that gap. And it's not going to bridge it to 100% completeness, but it will definitely fill a massive void in being able to detect sensitive PII, PHI, PCI DSS compliance, patterns that would be dictated as being sensitive and masked or anonymized or at least flagged or categorized. And this really helps in bridging that, especially with the nuances. A good example would be salary data. Typically you might apply an approach that's looking for certain keywords in a body of text, like salary, a person's name, and then some type of currency and monetary amount. That doesn't necessarily mean, because of those tokens existing, that that is considered sensitive. They might completely be talking about this in a different context. And these large language models are rather good at picking up on the nuance of when we're talking about a person's salary versus just a salary versus just a monetary value. So number 9, in this case, I think we'll, this is a little bit of surprise because last time Henri and I were here together, this made it to my top list, pretty much number 1. And I guess this also just shows how much movement there is in this space. And that is the enforcement of data policies and standardization. And I want to emphasize the last bit with actionable prompts. Let me translate this and break this down for us. Data governance programs are typically run very top-down, very prescriptive in nature, where we come up with these rules and policies about how we want to enforce the structure, the sharing, what we want our data to look like. And often this is just in the forms of written policies. They're not often codified. They're not something that's easy to actually enforce throughout the business. And it's quite fascinating to see that those exact policies that we would register in a data governance system are very close to the prompt that you would actually write to go off and transform the data. Once again, we're often dealing with data that we're wanting to transform that doesn't really have any, well-known patterns coming in, but we need to put it into a pattern on the way out. In this example, we're showing how we could take a phone number that might come in all different types of structure, without dial codes, without state codes, without region codes, different formatting with spaces, some without, some with hyphens, how we would put that into a standard like an E164 standard or an RFC 3966 standard. And for those of you who aren't aware, there are actually policies, ISO standards around data quality. So ISO 8000 is the standard for data quality, and there are derivations of this. ISO 8601, if I remember correctly, is for date formats. There's a different format for country codes, for currencies, and things like this. Not to mention, in different industries, we often have to speak different languages, speak different standards. In the health, we have FHIR, HL7, things like this. We have SWIFT in the financial services industry. And all of this requires being able to have your data formatted in different standards. The large language models, for sure, can help not only with detecting what type of data we're actually dealing with, whether it is a phone number, whether it is a social security number, whether it is a credit card, but also to be able to help put it into some standard without having to write huge amounts of code to handle all the different types of situations of a person could enter a phone number, a social security number, in structured or unstructured data as well. All right, number 8. So this is probably traditionally the more tedious parts of integrating and bringing data together, and that is having to trade semantics, map data between different systems. And this is not only being able to map different table names and business objects and domains, but also the column names that often exist between these. And it's not always going to be a simple one-to-one mapping. You might find that a certain column in one system, if it was to map into another model, it might need to split up into multiple different columns. And so this process is typically tedious and time-consuming, and in certain cases requires a lot of manual research to actually figure out what some of these columns actually mean. So when I was first exposed to this world, traditionally you would solve this using things like string distance functions, Hamming distances, Jarrow-Winkler, and you would measure the distance between the actual characters. So things like first and first name, or things like age and age range. There would be a certain overlap of characters. It would produce some type of weight, and you'd be able to put in some rules of when you would accept those mappings. Is it a 75% match? Is it an 85%? You know what? It doesn't really work that well, right? It worked great in specific scenarios, but in real life, it doesn't scale very well. And that's really where the concept of things like word vectors and word embeddings came from. And of course, in a later evolution, the large language models. And this was really about being able to measure the semantic distance between different words, where the characters didn't really have as much to do with each other. And the classic example is king and queen, in that the string distance between those is quite far, but the semantic distance between those is quite slow, is quite close. And of course, this relies on big models that have been built on all different types of languages to be able to measure those distances, to allow us to handle things where it's the semantics that we're wanting to map. Now, one of the nice side effects, and I'm not going to aim to say that I actually know deep down what this is. I can suspect that either the large language models have crawled certain websites. It would be amazing if it's the actual reasoning within the engines that have figured this out. But there are very well-known systems in the world, things like SAP S4HANA, Oracle ERP, the Common Data Model from Microsoft that runs under Dataverse and Dynamics. And these are well-documented data models, pre-existing models. And I can tell you that these large language models obviously understand these systems. They know what the KUN table from SAP is. They know what all the column names are. And of course, this gives you the hint that this could definitely be used to help us map semantics between these different systems. All right, let's move on. Number 7. So I will preface this with machine learning has already been very useful in this process already. But if you looked at the bread and butter of an MDM system, it's about building a single view of record. And in that, we require the ability to deduplicate records, to do entity reconciliation. And there's lots of different words for it, but essentially it's about being able to bring records together. And traditionally, we've handled this with a group of deterministic and probabilistic rules. And when you spend enough time with this, you start to realize that this also doesn't scale very well. In fact, you really have to go down to a record level and the nuance that sits there to be able to apply specifics at a record level. There's no real global rules that are always going to be able to deduplicate companies or people or vendors in a predictable way. Often we spend ourselves too much time playing with different weights and different percentages to try and shoehorn these results together. And the truth is, we have to go down to that record level often. And the large language models will not only help with this, but they're very good at explaining their reasoning. Why did I decide these two records were the same? And you can also ask it to be as detailed as you need. You might need to just want to hone in on why did it think these two addresses were the same, or why did it think these two first names were the same? And in the examples that we've been working with, very good at picking up nicknames, stems of names, all of these things that are really hard to actually code in a deterministic pattern. The other thing is that the large language model can often be used to help provide references. So as you are deduplicating records, you're often looking at in this tabular view, and you see that there's different values, but what you're probably not easy is there might be things like industry codes or industry specific terms that you're not aware of, but if translated to your language that you understand, you'd be able to figure out, oh, those are definitely duplicates, or no, definitely completely different companies, completely different people. So this will 100% be used in this space. So I've got about 5 more minutes and then we will serve up for some questions. So just as a reminder, if you have some questions, there's already a couple there, but please feel free to put those in. So this is the one that I'm most excited about. Even though I don't think it'll bring the biggest ROI, I think this is the biggest bridge that will happen. I strongly believe that the use of copilots and large language models in the space of data governance will really crack the data literacy challenge. Think about the way that we run literacy programs today. It's training, great. It's very top-down and prescriptive. We decide what business terms we want. We decide what we want to call different things. We decide what we want to call different domains. And then it requires a lot of constant training for it to sink in. I don't know about you, but I don't think a lot of people have a lot of time today, right? And although I'd love that to sink in like that, I don't think it scales very well. However, these large language models will bridge that by the use of copilots. A simple example. If I was to ask through a copilot, I need all of our customers, our products, and our transactions. With your custom models trained on your business glossary, data dictionary, etc., not only will it be able to facilitate the request, but through that, bring back the training into the actual response. So it might say, hey, listen, you asked for customers. I know what you were talking about. Here they are. But we actually call them clients. And we call them clients because of X, Y, and Z. And so there's that organic training that actually comes in the day-to-day use of the platform. And you might not use client on the next time, but then the training, the literacy will come back in that response again, making sure you can kind of move to the data literacy to ease that burden of being able to utilize the data. Number 5, proactive compliance. This is funny. About 2 or 3 weeks ago, I was in Boston with part of the Microsoft group, and we did a joint presentation. And during that presentation, I asked people to put up their hands. And it was, who in the audience wants to be a GDPR expert? Who wants to be a HIPAA compliance expert? Who wants to be a CCPA expert? No one put up their hands. And then I asked, is anyone in the audience against being compliant and against being regulated? Right? No one put up their hands. So the fact is, AI can help us with this proactive compliance in bridging this gap between not requiring us to be absolute experts on all of these regulations and the updates that come to them periodically, but to be that player that's being proactive and making sure we're scanning these different systems to be able to flag where maybe you might not be compliant, maybe you will be compliant, and what the application to become compliant would be. Number 4, we're getting close. So number 4 is cracking the unstructured layer. So I would say with the projects that we're exposed to, people are more comfortable with working with structured tabular data than working with unstructured data. And the fact is that these large language models are really cracked the unstructured part to the point where kind of early signs show that they work better on unstructured than structured data. And what this will help us bridge is this ability, kind of referred to as named entity recognition before, where we're picking out entities from unstructured and structured data and turning those soft references into hard references. And this will definitely help us on the defensive part of data governance, but it will also help us on building that single view. So we know where a particular company is mentioned within PowerPoints and Word documents, and this has just increased the accuracy of this. Number 3, we're getting close. So this one, I think, could have easily been number 1, but it was getting hard towards the end. And that is that AI to data governance will bring a new persona into the supply chain of data. It'll bring the non-programmers. It'll bring the non-coders. It'll bring the non-SQL people. It'll bring the people that are domain experts, but they know tax really well. They know audits really well. They know customer success really well, but they still want to play a role in that supply chain. And I think the market has settled, where data analysts have SQL, data engineers have Python, and these non-programmers will have the natural language of Azure OpenAI to be able to play that role. Number two, this one was an oddball, and actually I only added this a few days ago because of something I was experienced myself with one of our customers, and that is the impact analysis for change management. So this is something that I want to highlight. It's still very valuable to have very predictable ways to be able to analyze impact. And what I mean by this is if we're changing anything in our models, if we're changing anything in the keys, the foreign keys, we need to be aware of what downstream or potentially upstream impact that we're making. And of course, a lot of this can be handled with code, with logic, with deterministic rules. But when it comes to mass change across a business, AI can definitely be used to help adapt to those model changes, often in an augmented way instead of an automated way, but to help you make those reliable decisions and how you're going to migrate your changes so you're not breaking downstream or upstream consumers' use of the data. So with that in mind, we'll head to the last one and then we can open up for some questions. So number one, I'm really interested to see how many people spotted that this was the number one. But I also think Henri has touched on it a little bit. He led us into it with this, and that is the ability to build our own custom models. Our using the base layer models, but building on top with our own data. We all know the key to this will be feeding it with high quality data. High quality data that has audit trails, that has attribution of where that data came from. It has levels of trust in it. It's got multiple different sources agreeing on the accuracy and the uniformity and the standards of the data. And it's that data that we would want to feed back in to train in our models. And so that is the top 10 use cases of how AI will play a significant role in data governance. So Henri, I might welcome you back on the webcam and to just unmute yourself. I'll stop sharing my screen and then we can dive into the questions. So Henri, I'm going to start with you. Do you mind answering this? In the same way you've talked about building trust in the Copilot answers with web references, so the attribution via Bing. So yeah, can you give advice to businesses around quickly building up trust in AI and making sure it's not making unpredictable errors before you let it loose in the business?
Yeah, very good question. I'm gonna do it short, but three short elements of advice. Keep the human in the loop. So make sure that people are in control. That you're not generating the final thing and sending it out, but you're generating drafts that a human can review. That there is an audit trail as well that says, okay, this was generated by this model and potentially this configuration. I think that's important for creating trust as well. But also make sure, and let me just think, I had another really good point. Make sure that the so now I just lost it.
Maybe I can add.
Yeah.
Maybe I can add something here, Henri. Is that you talked about semantic kernel before, and semantic kernel is a library released from Microsoft, and one of the benefits of building on top of that is that it provides this playbook. So instead of you write a prompt and then it says, oh, I'm just about to do these steps. And then it gets a human to actually, oh yeah, that's what I wanted it to do. And think of that like training wheels in a way. But also I'd agree with your point, Henry, is that there is a 100% predictable way, is that every answer is behind a workflow process. And then the next question comes, well, how will that scale if I've got 10 million records a day? And in my exposure so far, it's literally just at that point, I'm sorry to say, it's like a risk game. How much risk are you willing to accept? Because it will not give 100% answers. And so that's the kind of risk mitigation you've got to have. Did you remember what you were going to say, Henry?
I did, yeah. Thanks for jumping in there. So the second point I wanted to bring up was that you always have the ability to do a second pass. So we've seen that, with these large language models, they only ever generate forward. They cannot go backwards and change something that they have generated in previously. So they go one token or one word at a time, and they will not go back and correct themselves unless you ask. So you actually have the opportunity to use either the same language model, or you can even use a completely different language model to fact check the first one. So you say, hey, this is what you just said. Given this, you stated this fact based on this supporting documentation, for example, or you answered this question with this answer based on this context. Is that correct? Would you say that is accurate? Right? You can ask the language model to fact check itself or a different language model, and that gives you the ability to actually, let's say, give the model a second chance to correct itself if it, for example, backed itself into a corner in the first time around. So that is definitely the way if you want to build trust into things that are reliable and to some way, avoid quirkiness. Then just by going over it with a second pass, you can filter out most of the unexpected results you sometimes get with generative AI.
I think it's always good to bring it back to how humans work. And if you were in a room and there was 10 people in the room, and you just asked one of those people, where is Lego headquartered? And that person said it's in Denmark. You would go, oh, okay, I'm going to put a certain level of trust in that. But I'm also going to ask the other people in the room to see what they say. And so you should think of Azure OpenAI in that as yet just another opinion or input on what could be the data or the transformation that's necessary. And you're going to take the ensemble of multiple different inputs to then weigh it up. Even if you were to buy, for example, data from a broker like Dun & Bradstreet, you could still get that. That could still be wrong. You're putting a certain level of faith, but if you had other sources that were not agreeing with it, you would also agree. You would start to go, wait a second, there's not alignment here. The same thing will happen with these. Okay, another question from Assam. How is OpenAI integrated with CluedIn? Is it something added as additional capability, or does it need to be used as two parallel applications? Okay, so probably some, like a lot of technologies you're seeing today, they will offer some functionality and then ask you to bring your Azure OpenAI token. And CluedIn is the same, is that it's got lots of capabilities that if you bring your Azure OpenAI key, it will then also ask the large language models to do something. And a good example would be our rules engine, where you can set up very deterministic rules that say, listen, if you spot a phone number, then please convert it into this standard. And instead of having a pre-built action that knows how to do that, we might want to ask the large language model to do that instead. And that also allows us to automate, in a way, these things to say, I don't want to have to do this for every record. I'm quite happy to set up this chain of automation that if we detect something, there's a known action, but I'm actually going, that action, all it does is write a prompt off to Azure OpenAI and then brings the response back and then continues on in the chain. Okay, maybe Henry, did you want to start with this one? What are the pros and cons of a general model over a naive model that's or specific model that's only trained on a specific use case?
Mhm. That's a very interesting question, because that's of course kind of where we were 2 years ago, right? 2 years ago, we had a lot of specific models, and whenever you wanted to do any kind of NLP workload, any natural language processing workload, you would have to train your own, you would take some base model and you would fine tune it with your own data to train it to a specific task. Suddenly we went away from that to these large language models that are very general. So I think that the question is super valid. The one pro that I see now with these large general models is that they are often so capable that they encompass many specific models without any need for training data. The fact that we can just say, hey, GPT-4, translate this to into this particular format. We don't need to train it to do that, but in the very next pass, we could ask it to do something completely different. So we can use the same model, the same endpoint, the same configuration with a lot of different tasks. And this is why it's being used in all of these copilots, chatbots, etc., where you don't necessarily know what the user might be asking for. In CluedIn, I think this is very interesting because, of course, Tim, you guys don't know what your users, what kind of format or what kind of rules they want to write, but they can do it, and the model supports it. This would be impossible to do if you had to train specific models for every potential use case, every potential standard, every potential thing that people might want to do. So, of course, if you have a use case that is super specific and you're never going to need anything else, you can still do that and train your own specific model. For most other use cases, I think these general models do a pretty good job.
I would agree. Henri, it's always good to be with you. We've got so many questions, it seems like we'll have to do another webinar in a month or two. I'm up for it if you are, but thanks for spending the time with us. Thank you, Henri, as always, and everyone have a good day.